now. Okay, so this is a topic that we knew was coming because it was announced last week. It's pretty much the leftover topic from last week's study hall that we didn't get to, or from 2 weeks ago. So statistics stuff. What we are not doing a whole ton of today is the arithmetic mean, because that topic is treated in a little bit more detail in our actual curriculum. But big topic today, standard deviation. Other big topic, median. Again, the main goal here is to complement our own course with some extra topics, which is why the emphasis on these is what it is. For instance, in our course, we have some coverage of arithmetic mean averages. We don't really cover medians and standard deviations too much in our 9-session course, so this is an additional session. But also some people wrote in asking questions about standard deviation and asking about medians, so we will go from there. We're going to start with the usual. It's kind of like when you get on an airplane flight, you do have to listen to the same old announcements about what you do, what you don't, safety instructions, all that sort of thing. Same thing here, the usual warnings about problem submissions and so on. Please, guys, pay attention to this one in particular. Do not submit problems that are too general. We've had a lot of people doing this lately, where people are saying, you know, how do I mean, a couple people are submitting things that basically, if you think about them, are asking us for our entire math curriculum in one question. Like, please don't submit things like, how do I solve math problems faster? I mean, that's way too general. It's not something we can answer in a study hall. Also, people are submitting things like, I need help with critical reasoning, which is potentially 20, 30, 40 hours of discussion, because that's all of critical reasoning. So this is the biggest offense here that people tend to be committing, is submitting problems that are way too general for the study hall. So please, when you submit a topic, try to make sure that it is something that could reasonably be covered in a segment of a 1.5-hour study hall. Also, not too specific. We have a couple of problems where people are just saying, here's one problem, what's the difference between these two answer choices? Remember that any question that you submit to this study hall, you can also post on our forums. If any of you don't have it, here's the address of our forum. It's www.manhattangmat.com/forums. So if your question is extremely specific and it really only has to do with one problem, then you should just put it on the forum. Because remember that any material that is accepted here is also accepted on the forum. So that's the division of labor. Like, the forums are there specifically for the purpose of taking care of specific questions like that. And the study halls are more for themed problems. Also, a couple of you are still doing this third thing, submitting your own personal study plan things. This is not the place for a personal study plan. So if you want to talk about, these are my scores, these are my priorities, here's where I want to apply, we have space for you to ask questions like that, but it's not here at the study hall. Like, where you would want to post questions about your study plan is in our general questions folder. And if you want to post questions about applying to schools and things like that, you would do that in the Ask an Admissions Consultant folder. Okay, also, don't forget, there's a couple of people asking questions in the text box. I'm not sure if you can see them or not, about other topics. If you are relatively new to this, please check out the archive of topics on the study hall page. Because one thing we don't want to do is repeat topics. We generally won't, because there are so many other things that we can talk about. So about a good 30 or 40% of the submissions that we get each time is stuff that we've already talked about. Like one person this week, for example, actually 3 or 4 people this week, submitted things like, how do I, go through the reading comprehension passages and read them and annotate. That's something we just did in a session a few weeks ago. One person asked about critical reasoning, find the assumption. We already had a study hall on that. So generally, the point being you should check out what is in the archives before you submit the problem. So that's a new warning, so to speak. So basically, please check the archive topics before making a submission. Because if your question is already covered in one of the previous study halls, then because there's so much new material that we can cover for maximum benefit, we're not going to repeat topics. Someone is saying that the recorded, I actually don't even, I don't even know what that means, Vimeo, instead of, I'm assuming it's another video site, but I know less than nothing about the internet, so, but I guess as long as the archives are up there, then they're up there. So the text box is kind of incidental because whenever people ask questions in the text box, I tend to repeat the question out loud and then answer it. So, and then if people are answering questions in the text box, you're not necessarily going to need to see that. So the integrity of the study hall should still be fine without the text box being shown. Okay. The other things here, please cite sources. A majority of the specific problems that were submitted in the last couple of weeks were cited without sources, which means we just have to ignore them. So the archives are on the same page that you needed to get here. So it's on the Thursdays with Ron page. If you don't know where to find that, you can just Google this term and it'll show up. Thursdays with Ron. The questions that you do submit, please try to be decently specific, but to tie into something that could be a study hall topic. So in other words, not too general, not too specific. It's okay to cite a particular problem as long as you have some sort of tie-in to a general topic. So don't just submit one problem and be like, I don't know the difference between C and D. Instead, if you submit one problem and then generalize, I don't know how to do C versus D here, and in general, this type of topic would be good for coverage. That's an ideal submission. Finally, no OG problems. We don't do official guide problems here because GMAC has asked us not to, and we want to respect that. Both because we have a good relationship with them and also because it's the copyright law. So if you submit an OG problem, basically we will just ignore it. Otherwise, please cite the sources. Even if you submit one of our problems, you still need to tell us where the problem is from. I mean, we have about 3,000 problems in our database. We certainly do not have them all memorized. So even if the problem is from Manhattan GMAT, you still need to give us the source. Thank you. Smiley face if you guys understand generally the things that are on this page. If you understand the types of things you should be submitting, types of things you shouldn't be, etc. Okay, good. So let's go ahead and jump into it. Remember that we're talking about statistics today, and we're going to start our discussion with a discussion of the standard deviation. So, in particular, there are things that you have to know about the standard deviation, and there are other things that you don't so much. So let's take a brief survey here really quickly. Standard deviation. First of all, I'm going to open up the floor to this question. What is it? What is the standard deviation? So see if you can, text box, go ahead and give me some answers to this. I'll give you about 15, 20 seconds or so to answer it. What is the standard deviation? Okay, I'm liking the answers that most of you are giving for this. In particular, this is a problem that is tested in a very, very conceptual way. So what you do have to know is very, very, very conceptual. Right? In other words, what you do have to know is basically what most of you are writing. The standard deviation is a measure of spread. And what spread means is basically how dispersed are the data, how widespread are they. So the farther the data are from the mean, on average, the larger the standard deviation. The closer they are to the average, the smaller the standard deviation. Things you don't have to know, and only a couple of you were mentioning this, but what you don't have to know is you do not need to know the exact particulars of how to calculate the standard deviation. In other words, there's a really ugly formula for it that involves a square root and all this other stuff. In case any of you are going to point out, yes, the official guide does describe how to calculate this. So if anybody was going to write that in the text box, I'm going to anticipate that objection. Yes, this process is described in the math review part of the OG, but it has thus far never been tested on the official problems. And this is not a small sample size either. Like between the guides and the GMAT prep, especially GMAT prep, there's been something like 15 to 20 problems involving standard deviation, and not a single one of them has ever required you to calculate the standard deviation. Instead, the only thing you have to realize is, how do I make the standard deviation bigger or smaller? So let's talk about that. Here's a data set. Let's go ahead and put a data set on a number line. And then we'll talk about how to make it bigger or how to make it smaller. So let's make the data set have about, I don't know, 5 or 6 points. So, and just for easy discussion, let's go ahead and make the data set approximately symmetrical. Okay, here's the original data set. So this data set has a certain standard deviation. For the person in the comments who's asking about the bell curve, no, you don't actually need to know anything about formal statistics. So, I mean, they may talk about distributions of scores and percentiles and stuff, but you don't have to have anything memorized about normal distributions. So if that makes you feel any better about that. Okay, here's our data set. Let's take a look. Who knows what you could do to this data set to make the standard deviation bigger? So it's a question for the text box for the audience. What would you do to increase the standard deviation? Remember, you can't move the data points, but how would I add additional data points that would increase the standard deviation? Not moving the blue points. You can't move the blue data points. So go ahead and answer this. I'll give you about 15 or 20 seconds to answer it. When people are saying multiply them by something, that's changing the data points. Like, you specifically cannot move these data points. You cannot manipulate the existing data points. You have to add additional ones. Okay, yeah, you guys are starting to get it. A lot of you have posted it correctly in there. So the one thing you can do to guarantee that you will increase the standard deviation is to add in points that are outside the current range. So I mean, the standard deviation measures how spread these data are. So if you add points that are this far out, I mean, let's make the idea of spread a little bit more exact. It's not how spread the points are away from each other. It's spread away from the average. It's like distance from the average. That's a better way of saying it. So that's basically what standard deviation is. That's not exactly what it is. It's not technically the exact average distance from the average, but that's the best way of thinking about it. So if you add in extra points that are farther away from the average, then the standard deviation will definitely go up. So smiley face if this makes sense. Smiley face icon over there on the left. Other face if this doesn't make sense. Okay. What about the other way around? Remember, we're still not, for those of you who are saying scatter it or multiply these by something, that's not the current issue. The current issue is we can't touch the blue points at all, but we're adding in additional points. So how would I add additional data points that would decrease the standard deviation? Text box, please. How would I add additional points that would decrease the standard deviation? Yeah, you guys are pretty much answering this in the comments, so good. You add points that are either on the mean or are closer to it than the existing points. So you would add new points that are on the mean, or at least closer to the mean than the existing points. I mean, this is, again, it's a very conceptual idea here. I mean, there is the notion that you could add, okay. You can add points like that are right in the middle of the data set, and then you're not really going to be able to tell without calculating. But again, the point is these problems are written in a way such that you do not have to calculate anything. So it's important to realize that. So they're not going to ask you what happens, for instance, if you put new points in right here and right here, because then you would have to actually know how to calculate this stuff from the formula, and that is exactly what they do not want to test. So smiley face if the stuff so far on this page makes sense. Okay, one gentleman is asking in the box, are you using the average of all the points? Yeah, it's the distance from the overall average. So just for simplicity, I've drawn a set that is symmetrical about the middle. But it's the same deal for any set. It's how far away are they from the average. So there you go. Try this problem. I'll give you, again, if you've never done one of these study halls live before, weighted average is the average. So, I mean, if it's a weighted average problem, they're not going to ask you about the standard deviation in the same problem, because those are kind of different ideas. They're not going to be so stats heavy that you won't see those in the same problem, basically. But technically, yes, they could multiply. Okay, this problem, here's how we're going to do this. I'm going to give you some A through E choices in the corner. You should see those appear just now. They should be over here on the side of this box, near where the smiley faces are, but farther to the right. So this is the way we usually do this, but if you're new here, a quick explanation. Please do not answer in the text box. Please use the A through E to the left. And then I'll give you a timer. And at the end of the timer, we'll have a discussion of the problem. So I'll put about 1.5 minutes on the timer. Okay, time is called, so please indicate an answer. Remember, if you guys have to guess, go ahead and guess. Remember, the functionality of this test is that you have to guess. Like, there's no such thing as leaving a problem blank. or anything like that. So even if you are sort of confused, please guess in the next like 5 seconds or so. There's a Dinesh, Diana, Akhilesh. You guys don't have answers yet, so please guess. Okay. Time left, 3, 2, 1. Okay, here are your answers to the problem. The group did get this one correct. Here's a quick summary of what's going on in the problem. First of all, let's interpret the problem where D is positive. Let's make sure we know what that means. What's the significance of that? In the text box, go ahead and tell me what does that matter? Like if I tell you that standard deviation is positive, what does that mean? When you answer this question, remember that standard deviations can't be negative. There's no such thing. Like, the standard deviation is the best, again, it's not exactly what it is, but the best way to think about it. Standard deviation is basically the average distance from the data points to the mean. Okay, it can't be negative because you don't say, there's no such thing as a negative distance. So it's not like a coordinate geometry type problem where you assign negative and positive distances. So what does it mean then that it's positive? I mean, what do we know that always? Quick, how many? This is going to sound like a stupid question, but let me ask you what sounds like a stupid question. Like positive is a sign, right? Negative is a sign. Here's a stupid question you can answer in the text box. How many signs are there? I know that sounds like a dumb question, but give me an answer to that in the text box. How many signs are there? Yeah, you guys are, most of you who are answering the question in the text box are giving me what I'm looking for here, which is, it's a really important thing. There are 3 signs, not just 2. So, positive, negative, and 0. 0 is a sign, which is different from positive and different from negative. So the significance of telling you that the standard deviation is positive is that it's not 0. So this statement basically just means that the standard deviation is not 0. In other words, there are points that are not at 6. I mean, this is significant because if you were not told this, then there would be a possibility of having every single data point exactly at 6, which would be a 0 standard deviation. And then this would be impossible. You can't make it go down. So if you read the problem, then what you're trying to do here is you're trying to decrease the standard deviation. You're trying to make it smaller. I mean, they're putting this in code language a little bit by talking about this thing called D. But D is the original standard deviation. You want it to be less. So basically, this just means you want to make the standard deviation smaller than it is. So we talked about how to do that on the previous page. To make a standard deviation smaller, you have to add in points that are closer to the mean than the existing points are. So the problem is, in this case, we know there are points that are not on the mean, but we have no idea where they are. So if you want the standard deviation to become smaller, there's only one way to be absolutely sure of this, which is we need to add points that are closer to 6 than the existing points, than at least most of them. I mean, again, there are exceptions to this. There are freakish sets where standard deviation does strange things, but you don't need to worry about that. They're not going to ask you things where you would need a statistical knowledge to figure it out. So we need to add points that are, the questions in the text box, don't worry, I'll get to them. I'm not going to interrupt the discussion right now to answer the questions, but I'll get them. Okay. We need to add points that are closer to 6 than the existing points are. The problem is we don't know where the existing points are, though. So the only way to be sure of this, is to add points at 6. Hold on a second. Because you don't really know where any of the other points are on the number line. So for instance, you know, your set could look like this. I mean, you could have 100 data points that were all between, you know, 5.999 and 6.001. You could just have a ton of data points that were all along there. So if you had, for instance, your data set like this, right, you might have a whole bunch of points like this where they were all between, you know, here's 6, here's our average, here's 5.9999, and here's 6.0001. If your set looks like this, then this illustrates why all the other choices could be wrong. Because if you take, I mean, I know I didn't draw 100 points, but imagine this is 100 points. If you had a set like this, then adding any of the choices A, B, C, or D would drastically increase your spread from the average. Because if you add a 0 or a 12 into this set, it's going to be either like miles over to the left or miles over to the right. Yeah. On the other hand, if you add points that are right here at 6, then no matter what, those are going to bring down the standard deviation. So this one is E. Any questions about that? Smiley face over here if that makes sense. Questions, if you have them, type them in the text box. If not, I'll get the ones that are in there right now. Okay. The question here, can you say that 0 is the minimum standard deviation? Yes. If you have a 0 standard deviation, that means every point is right on top of the average, and it's impossible to be less than that because, again, standard deviations cannot be negative. If you had to increase D, that's actually a good question. Let me put that to the class. Would it be possible for any of these choices be guaranteed to increase the standard deviation? So let me reproduce this onto the next page here. The question is, for you people in the text box, would any of these choices be guaranteed to increase the standard deviation? I'll give you a few more seconds to put some opinions in the text box. So none of them would. Because again, remember what you would have to do. To increase the standard deviation, you basically have to add points that make the data more spread away from the average. So you would have to, unlike decreasing, like you know that if you add points at the average, you are going to decrease the standard deviation because you're adding points that are right on top of it. The problem is you don't really know if you are increasing the standard deviation unless you know where the other points are. So for instance, none of these would be guaranteed to do that because your set could be, for instance, something like this, where you have a number line. Remember, your data points are allowed to be the same. So let's say you have 2 data points at, let's just pick 2 numbers whose average is 6 to make this easy. Let's say that this is -100 and this is 112. And I have 50 data points here, and I have 50 data points here. Or these exact numbers are not important. The point is just that these are two numbers that are really far apart, whose average is 6. So, and since they're equal weight, you're just going to have the average between those two numbers. So the average of all of these is going to be 6. So this does satisfy the hypothesis of the problem. Needless to say, these are all a lot closer to the average than these things are. So if you add in the data points in any of these 5 answer choices, then it'll get smaller. So adding any of the 5 answer choices will make the standard deviation smaller. Okay. As for the person in the text box saying, I think we are spending too much time on this, thank you for your extremely constructive comment. That is great. Okay. Any other questions about this problem? If not, smiley face if you're ready to move on. Okay, now let's have a discussion about, back to the basics of standard deviation. What is it? Now let's talk about, remember, you don't really have to know how to calculate it, but you do have to have a sense of when the standard deviation is big and when the standard deviation is small. So here's 2 sets that have the same average, but different standard deviations. Okay, in fact, instead of 2, let's do it with 3. I'm going to give you 3 sets that all have an average of 10, but that have markedly different standard deviations. So, okay, 3 number lines. Constructing number lines in this program is a little bit annoying, so pardon for the delay in doing that. Okay. All right, let's make an average of 10 for each of these sets. Let's say that this is 10 in all 3 of these. So we're going to have an average at 10. First set, let's just say that you've got 5 data points that are all right at 10. So 5 points right here. Second data set, cluster them pretty closely around the mean. And then third data set, put them extremely far away. So this is a pretty basic illustration, but I just wanted to make sure you guys get the point. And then just to make sure the scales are the same on all of these. So let's say, for instance, that this is 0 on both of them, and then this is 20. The point of this slide is just to make sure that you have the understanding that what is the standard deviation of the first one? Please tell me in the text box. What's the standard deviation of this set? 0, right? And then this is a non-zero standard deviation, but it's smaller. And this is a non-zero standard deviation that is larger. So that's actually all you really need to answer a lot of these things. So based on that kind of understanding, go ahead and try this one. Let's do a timer again with about 1:30 on it. And same deal, please answer the question with the buttons on the left. Thank you. Closing in on a minute and a half, minute 45 here. So if you need to guess, please guess. Remember, a defining characteristic of this exam is that time pressure is important. So if you don't have an answer, please try to have one. Okay. Please try to answer in the next 5 seconds if you are Al or Diana or Garima or the King. Okay. Here's your answers to this problem. Again, there are a few abstentions here. Remember, when you do this, when you take the GMAT, you really have to, I know I emphasize this in each of the study halls, but remember that you do need to answer every question that is put in front of you, and you have to do it in a timely way. So I know some people step away from the terminal, but if you are here and you're still not answering the problem, that's a habit that you're going to want to overcome. Okay, so standard deviation, you don't need to calculate it to figure this out. Instead, it's just we need to figure out when these things are closest to the mean. So you want it to be the least. Standard deviation, the least distance from the mean. So least distance from the mean. This means when are the data points closest to the mean. So one thing you probably noticed about these sets is that all 5 have the same mean. All 5 have mean equal to 5, which is convenient because then we can just picture it 5 times. You don't necessarily have to draw these things, but if you have trouble with visualizing this, then you absolutely should draw them. So let's copy and paste that a couple of times to slow down, increase the task speed here. Okay, so wow, ugly. All right, looks like we have to move some of these pieces of number lines around. But doing our best here. Okay, let's make these number lines so that they have an average of 5. It's kind of hard to move these pieces around, so apologies for that. Okay, so the average on each of these number lines is going to be 5. And let's just picture this. You can knock off a lot of these by just picturing it and just realizing when these things are closer and when they're farther away from the mean. So in each case, this will be 5, and then we'll say 3, 4, 5, 6, 7. Okay, so let's bring the question back into focus here. We want the standard deviation to be the least. So operator A is really far away. Like these points are, you've got 2 points all the way over here, and you've got 2 points all the way over here. Operator B, you're talking a little bit closer. 4, 5, 5, 6. Operator C, you've got 2 here at the mean, but then you've got 1 way over here and 1 way over there. Operator D, you've got 2 at 4 and 2 at 6. And operator E, you've got 3, 4, 5, and 8. So now remember, it's just a comparison question. There's no need to go through lots of calculations. So for instance, if you compare C with B, notice these 2 points match these 2 points, and these 2 are closer than those 2. So B has a smaller standard deviation than C. So we can cross off C. Smiley face if that makes sense. If you do this comparison of B versus C, you've got comparable points you can just ignore, so then the ones that differ are closer in choice B. The question in the text box, is it fair to assume the average would have been the same? Absolutely not. You need to calculate that. I mean, that's why they made the numbers really nice. Like they're not gonna, they're not gonna make horrible numbers and make you calculate that kind of thing. But no, sometimes they'll tell you. Sometimes they'll say the mean is the same. But in this case, they don't. So you actually should verify that that is the case. If you look at A, every single thing in A is farther away than in B. So A is out. If you look at E, then you can match this point with one of these. Then this is farther away than that. This is farther away than that, and this is farther away than that. So you can get rid of E by making that observation. So between B and D, let's take a closer look. Well, notice what you've got. I mean, you have 2 points that match each other exactly. You've got this point that matches this one, and you've got this point that matches this one. But then of the points that, so those are going to contribute equally to the standard deviation because they're in exactly the same place. But then of the ones that don't match, what you'll notice is they're farther away in choice D, like dog. So this is going to mean the standard deviation is lower for choice B. I mean, in other words, think about it from this point of view again, where how do I make the standard deviation go down? Well, you take points and you move them towards the mean. So that's basically what has happened here. Basically, to get from D to B, you would take 2 of the points that are in D and you would move them closer to the middle. So B is going to be smaller standard deviation. Any questions about that? Smiley face if this makes sense. Again, notice that there are no calculations required to do this. Okay, smiley faces are good here. I want to re-emphasize what I had at the very beginning, because I know some of you were not here at the beginning of the session, which is this. The official guide, if you read the math review part of the official guide, it does talk about how to calculate standard deviation, but I think that's just a distraction. Because we've seen a large number of these problems, and in none of them do you ever have to calculate a standard deviation. I mean, and it's not unique in that respect either. There are quite a few things that are described in the opening reviews that you just don't have to deal with. For instance, the quadratic formula is in the math review too, but we've never seen a problem where you have to use it. There are some aspects of sentence correction discussed in the grammar review that have never actually been tested. So the OG does have a couple things in there that just aren't in the test as far as we know. Okay. Let's move on to a different kind of standard deviation problem, which is this one right here. Let me just throw this at you and see how you do on it. Yeah, you should always be able to use a conceptual method. I mean, if you're a lightning wizard at calculating it, of course you can, but this is the other major type of standard deviation question. So I'm just going to toss this at you and see how you do on it. Again, please answer using the A through E buttons at left. As you'll see, this is a different kind of problem entirely. I'll give you about 1:40 on this one. Have fun. Okay, a lot of people don't have answers to this problem, so let's guess if we need to. Remember, this is the GMAT. You do have to answer the problems. So even if you do not have a clue, it would still be instructive to see how you guys guess. And also instructive for you to get used to guessing also. So if you are Al, or I don't know if that's Al or AI, Diana, Garima, or Paul, please guess in the next few seconds. Thank you. Okay, here, yeah, thank you, I noticed that. Okay, so a couple answers we're waiting on. Here's the class. So basically it looks like the class is just guessing this at random. Because this is a pretty evenly distributed suite of answers here. So good, we're going to have some learning going on. We like that. Let's segue into an analogy here. Let's say that I ask you the following question. Let's say that I know we have a lot of viewers here who are from other countries, so just to make you guys happy, let's say that I'm 100 centimeters tall. All right, now let's say that my hand is 10 centimeters wide. Okay. If I say that someone is within 1.5 hand widths of my height, what does this mean? Text box, please. What does that mean? Yeah, all right, they're starting to pour in here, the answers. So what's interesting about this is you don't really have to know anything about a hand. All you have to do is just realize what within means. So within just means in either direction. And then at most. So that's what the within part means. And then 1.5 hand widths means you don't have to even know what a hand is. All you have to do is just take whatever I tell you a hand is and just multiply it by 1.5. So what this means, 1.5 hand widths is 1.5 times whatever I tell you it is. So that's 1.5 times 10. And then of my height, so that means it's a distance from my actual height. So you're just going to take my height and subtract and add that much, and that's it. That's the end of the story. So that means you're just going to take 180, and since it's within X amount of, that's plus or minus. And then 1.5 hand width turns out to be 15 centimeters. So this means someone's height is at least 165 and at most 195. And notice that when we talk about within, I'm not sure if they're going to nitpick to this level to make sure you can do it if they do. Within actually means it has to be like 165 and 195 would be okay values. Believe it or not, this is all you have to do in this problem. Like if you see problems like this, and this is a very consistent pattern that we've noticed in a large number of GMAT prep problems. By the way, this problem, every problem in this, just so I can give an attribution, every problem in this slideshow except one is from the GMAT prep official software. So this is from GMAT prep. So the standard deviation, it doesn't even matter. Like in problems with numerical values for the standard deviation, you can treat it just like it's a hand width. You actually don't even have to know anything about the standard deviation. You don't have to know any facts about what the SD means. Just treat it like hand width in the other problem. So you just need to be within 1.5 standard deviations of the mean. That's exactly like being within 1.5 hand widths of my height. So this just means it's got to be the mean plus or minus 1.5 times whatever the standard deviation is. So the mean is, when they tell you what the mean is, it's 8.1 plus or minus 1.5 times the given standard deviation is 0.45. So this means anywhere from 7.65 to 8.55. And that's actually all it is. You just have to calculate that, and then you just have to go count things. So the things that are in this range, there are a whole lot of them. Just go up here and figure it out. So let's find everything between 7.65 and 8.55. No, yes, 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 and yes. So it looks like 11. And yes, this is really all you have to do. It's not any more involved, believe it or not, than this. And this is something we've actually noticed consistently in official problems that use numerical values of standard deviation. This is not just one freakish problem that happens to be easier than it looks. It's like all of them. So does this make sense? Smiley face if you guys understand this explanation, not smiley face if you don't. I mean, it's a little bit of like punch yourself in the head kind of thing after a while. But like, here's some more. of this. Like this is also an official problem, and so is this. We're not going to work these together, but these require the same complete lack of understanding of what the standard deviation means. Like D here is a standard deviation, but it doesn't matter. You're talking about a symmetric distribution, so this could be a hand width as much as it could be a standard deviation. This also could be. 98 was 3 hand widths above the mean, so this is literally just saying mean minus 2 hand widths is 58, and mean plus 3 hand widths is 98. That's all it is. So, what about, Al says, what about Q with relation to median and mean? I'm not really sure what you mean by that. I mean, this question is related to the mean. Like in this case, you had to use the relationship. You had to actually calculate using this mean and this standard deviation. So that is an example of that. Median, there's no easy way to think about that. So they're not going to have you tie those two concepts together. But this problem does relate those things. The analysis. Well, I'm not sure which question is the analysis question. Is that a question from this study hall? Not real sure what you mean. So if you could tell me in the text box, that'd be great. In the meantime, we should probably move on to some problems involving the median. Remember our other promised topic from today was, okay, Al, I'm not sure what you mean, so if you could maybe submit one on the forums or on the in the study hall submissions, that'd be cool. Okay, but it probably is not any more complicated than what we're doing. There are lots of more complicated problems involving median and mean, but not also standard deviation. Not that I've seen. So, because they're trying to, yeah. Question in the text box says, why do we multiply by 0.5? Do you understand why we did this? Why we did the 1.5 times 10. It's the exact same thing. 1.5 hand widths is not 1.5. It's 1.5 hand widths. Same thing here. This is not 1.5. This is 1.5 standard deviations. So it's 1.5 times what the standard deviation is, just like a hand width. I mean, if that's confusing, then in problems like this, you can actually take out standard deviation and put in hand width, and it will still work. Like if I say these data have a mean of 8.1 and a hand width of 0.3, how many of them are within 1.5 hand widths? It will absolutely still work. So the person who asked that question, smiley face if that makes sense. Okay, all good. So let's move on. The other promised topic from today was the median and its relationship to the mean. So let's move on to that and see how that goes. So here's a problem. I'm going to throw it at you out of nowhere. I'll give you 2 minutes to work on this. Again, please use your buttons to indicate your answer. Please, 2 minutes. Have fun. Minute and a half, so please try to have an answer in the next 30 or 40 seconds. Okay, that's 2 minutes, so please in the next 15 seconds or so try to indicate an answer. So people with answers not there. Al, you had one, but then you took it away. Diana, GB, Girish, Gopalan, MDLE. If you could give me an answer, please, that would be good. Okay, so we are absolutely all over the place on this one. The class did pick the correct answer most often, but it was only about 33%. So definitely, yeah, we're going to need to do some stuff here. Median, first of all, make sure you know what the median is. Okay, text box, go ahead and tell me what the median is. Let's make a quick slide for that. Well, what is the median? Yeah, a couple of you guys are saying average. I mean, if you mean average like mean of the set, then no, that's incorrect. But if you mean, it's a way of measuring, like, it's one way of thinking of an average, but it's not the same thing as the regular average. The median is if you have an odd number of data points, then it's the middle value when the values are ordered. So, for example, if your set is 3, 5, 8, 11, 17, 24, and 33. This is an odd number of points. The reason why it matters whether you have an odd or even number is because the only way you're actually going to have a middle value is if you have an odd number of points, because then you're going to have a number in the middle and you're going to have the same number on each side of it, creating an odd number of points overall. So the median of this set is 11. Now, if you have an even number of points, it's a little bit different. If you have an even number of points, then it's the mean of the two middle values. So if your set was just 3, 5, 8, 11, 17, and 24 without the 33, then in order to find the median of that set, you would actually have to average those two values. So in this case, the median is going to be the average of 8 and 11, which is going to be 9.5. So now the question is, what do we do? So that's a definition of the median. Make sure a smiley face if this makes sense, if you're down with what the median means. We occasionally get students who don't, so give me the other face if you're not okay with that. Okay, now let's talk about how to deal with the median. Like when you deal with the median in a problem, if you see a problem that deals with the median, then the best way to deal with it, because it's not anything that you can like make a formula for. It's not like the mean where you can just say it's the sum divided by the count or something like that. You can't write a formula for it. So instead of writing a formula for it, what you should do is you should set up ordered blanks. I mean, that sounds like a really fancy name, but it's really not. It just means that you set up a bunch of blanks. So in order, where it's understood that the one on the left is the smallest. So for example, if I have a set of 7 numbers whose median is 8, then I would just set up 7 blanks and put an 8 in the middle blank. I mean, this seems like it's trivial enough, but judging from the performance in the last question, people are going to need some help with setting these things up. It's just nice to have an organizational tool, is what it is. So there's your smallest value over there and your largest value over there. The reason this helps is because you know all of a sudden a lot of stuff that you wouldn't immediately know if you just were thinking in terms of random variables. For example, like we know that these numbers must be 8 or less. And we know these numbers over here must be 8 or more. And if you don't use a set of ordered blanks, it's actually extremely difficult to keep track of all of this. Like you might find yourself swimming in a sea of variables that just gets incredibly confusing after a while if you don't. So, ordered blanks. Smiley face if you guys understand this whole principle of ordered blanks. Okay, so let's go back to this problem, this one right here. So it's 3 boxes of supplies, so that's not a whole lot, but we should still make 3 ordered blanks because there's 3 boxes. So we need a set of 3 ordered blanks. So 1, 2, 3. And then it says they have a median weight of 9 kilograms, so you've got a 9 here. And then because these are ordered, we absolutely know that this is 9 or more. And we absolutely know that this is less, or 9 or less. So there you go. The only other issue here is, what do we do with this? Who knows what we should routinely do with averages if you don't know what else to do with them? Text box, please. What should we do with this by default? Yeah, you guys are getting this. Let's put it on the board just for the sake of your notes. If you see an average and it's not immediately apparent what else to do with it, then just find the sum. Because you have a formula. I remember there's two formulas. It's sum equals, or the way you find an average in the first place is average is the sum of all the numbers divided by how many numbers there are. And so you can rephrase this into a product. You can make it how many times average equals the sum. So you really don't want to be setting up equations with variables and stuff like that. That's just kind of overkill. Just find the sum. So in this case, we have three terms. Average is 7. And so the sum must be 21. We're setting up a two-variable equation is just going to be a massive time sink here. And even though you could handle that here, if I give you a set of 5 boxes or 7 boxes or something like that, I mean, it's not something that will scale up, is what I'm trying to say. Like, this is a small enough problem that you can get away with it, but a lot of these have lots of data points in them. So you are trying to find the maximum weight of this. Now, here's a consideration that I think we've visited before in one of these study halls. If you want to maximize something, what does that really mean you have to do? Text box, please. If you want to maximize that quantity, the real task is to do what? Yeah, you have to minimize the other quantity. So the minimum value of the other one is 9, because it can't be anything less than 9. So this is the advantage of ordered blanks. If you don't put these in order, it's not going to be obviously apparent that this has to be 9 or more. But you're minimizing a number that has to be at least 9. So you just put a 9 there. And then since your sum is 21, you just take the existing 2 numbers away from 21, and that gives you 3. So this one is C. Lots of takeaways from this problem. Again, you don't want to be memorizing the entire problem, because chances that you're going to see a problem like this again, very slim. Slim chances indeed. But the takeaways here are really important. First of all, when you see a median, your immediate reaction should be to make ordered blanks, because all median problems will benefit from ordered blanks, all of them, every single one. Then when you see an average, this is what these guys do. They give you stuff that doesn't really mean what it says. So average doesn't really mean you should be thinking about average. It means they want you to find the total. Median doesn't really mean just median. It means you want to order all the blanks, and so on. Maximize this quantity really means minimize the other quantity. So this is the kind of problem that's very resistant to memorization, but if you kind of understand where you can go from these things, it'll help you a lot. Questions in the text box, otherwise give me a smiley face if you're ready to move on to something else. Okay. I mean, again, it's not bad to have an algebraic approach to these kinds of things, but if you're defining a separate variable for each quantity, you should be acutely aware of the fact that that will not scale up without a lot of pain. So it's helpful to be, more conceptual about this kind of stuff. Okay, let's try another problem. Here is another one. Thank you. Thanks for the kind words, by the way. I appreciate that. Let's try that one. Okay, here's a timer. I'll give you 1:45 seconds. Again, please do not answer. A couple of you have signed in halfway through. There's buttons on your left. Please use those. Please do not answer in the text box. Thanks. Okay. Take another 20 to 30 seconds to answer this one if you need it. And then we'll have a discussion. This one is extra fun. Again, there's a couple of people answering in the text box. As I mentioned at the beginning of this problem, please don't do that. Please use the buttons. The buttons are over there. There, A, B, C, D, E. They should appear underneath the names. Thank you. Okay, people who don't have answers yet, that is Diana Chang and Garima 1 and Jesse Shi. Other than that, looks like people, and SKR. Okay, remember if you're not answering the problem, remember the GMAT does make you answer the problem. So it's useful to just get a guess off of your chest. But there are 3 people who didn't answer. Let's take a look. This one again is a mixed bag. Let's use ordered blanks. And let's think about it. So 1, 5, -2, 8, and n. The first thing to do is put those 4 things in order. That's kind of not in order right now. By kind of, I mean it's not. So the current numbers are -2, 1, 5, and 8. The issue here with filling in the ordered blanks, in the text box, where's the issue with this problem? Is we don't know what. See if you can tell me in the text box. N is unknown, and more to the point, we don't really know where n goes. So remember the ordered blanks. Now the problem here is that there's going to be different possibilities for this because we don't know where n goes. So here they are, and I mean what it's best to do, and this is a general data sufficiency tip, like for pretty much all the time. If you ever encounter a situation with a small number of possibilities, then what should you do? Really, really important. Like I bet a lot of people got stuck trying to write formulas on this problem. Yeah, you guys are getting it. You should just list them and like list first and ask questions later kind of thing. So if you ever encounter a situation where there's not that many possibilities, just list them. Really important. So here's our ordered blanks. We don't really know where the stuff goes in the ordered blanks because n could be anywhere. So if you could have, it could be n and then all of those numbers. It could be -2 and 1, 5, 8. It could be -2, 1, n, 5, 8. It could be -2, 1, 5, n, 8. Or lastly, it could be -2, 1, 5, 8, n. And then on top of these things, there's also the possibilities where n actually equals one of these numbers. So I mean, there's also 4 more possibilities where you've got n equaling -2, and so either of those blanks. You've got the possibility where it's -2 and then n equals 1, so you have those. And then you have the possibility where, thank you, you have the possibility where n equals 5. I mean, this looks like an obnoxious number of possibilities, but really at the end of the day, it's not. And the thing to realize here is that once you've listed all of this, it should be immediately apparent what is happening. So there's all the possibilities. So let's number these. Let's say this is possibility number, let's say this is A. I don't want to use letters. This is possibility number 1. This is possibility number 2. This is number 3. This is number 4. This is number 5. This is number 6. This is number 7. That's number 8. That's number 9. Okay. So the median of the numbers is less than 5. Like as soon as you've enumerated these possibilities, it just becomes a matter of just seeing which possibilities work with which statement. So which possibilities work with statement 1? So in the text box, please tell me which possibilities work with the first statement. Some people are saying 1 through 6. 1 through less than means less than, and this means not 5. So in possibility 1, 2, and 3, and 4, the median is 1. So that's fine. In possibility 5, we're talking about a number between 1 and 5, so that's less than 5. But number 6, no, because in number 6, your list is -2, 1, 5, 5, 8. So in the case number 6, this is false because the median actually is 5, and 5 is not less than 5. So this statement works only with possibilities 1 through 5. Smiley face if that makes sense. I know a bunch of you are putting 1 through 6. So give me a smiley face icon if this is okay. And give me the other face if it's not. Okay, one other face. Again, possibility 6 is not okay because the list in possibility 6 is -2, 1, 5, 5, 8. So the middle number of those is 5. So this is false because then 5 is not less than 5. In fact, maybe instead of doing that, we could just write it as this. That might help. This is actually 2 -2s. This is 2 1s. One of those is n. This is 2 5s. And this is 2 8s. That might make it more clear what's going on here. So in the blue cases, one of those numbers is n. So smiley face if that makes sense now. Okay, so looks pretty good here. All right. In particular, the gentleman who asked the question. Does that make more sense now? Okay, so so case 6 doesn't work. Which possibilities now in the text box, which possibilities work with statement 2? The median is greater than 1. Yeah, so you guys are saying this. This is correct. It's the ones from 5 through 9. Because in statements 1, 2, and 3, the median is 1. And actually in statement 4, it's also 1. So these 1 through 4 don't work. But then here, n is bigger than 1. And then the median of 6, 7, 8, and 9 is all 5. So these are 5 through 9. And now we do have to answer the question. The question is n between 0 and 7? So with statement 1, with impossibilities 1 through 5, n could be anything less than 5. So if you're looking at this, like in possibility 1, n could be like negative 20,000. So that would be a definite no to this question. But n could also be numbers between 1 and 5, which would be a yes to this question. So that's insufficient. Second statement, you're looking at n that could be between 1 and 5. It could be 5. It could be between 5 and 8. It could be 8, or it could be 10 billion. So in possibilities 5 through 9, n could be anything more than 1. Also insufficient. But if you combine them, if you put them together, then case 1 through 5, case 5 through 9, the only way to combine that is case 5. So then you know that you still don't know what n is, but n has to be between 1 and 5. So it's not sufficient to find n, but it's sufficient to answer the question at hand. So this is going to be C. There you go. Smiley faces if this is all good. If you have any questions, tell me what those are. Okay, looks like we're all good. All right, let's see if we can bang out one more problem here before we have to call it a day. So let's do it with this should be doable in 2 minutes. I mean, it's really just knowing that there are a bunch of possibilities, but this is not something you couldn't do in 2 minutes. The only way that you would really be pressed for time is if you stared at it forever and tried to figure out algebra first. Like, again, as we've stressed so many times here, it's an issue of just being quick to try things. If you are not going to get an algebra solution right off the top of your head, then quit. Don't keep trying. Try something totally different like this. So there you go. Is there a way to do it without writing down all the possibilities? I don't really know why you would want to. There's definitely no reason to be afraid to write the possibilities down. I mean, this is not something that takes that long. It's just not, I promise you. Like, it should take about 3 or 4 seconds to write down each of these possibilities. So times 9 is it should take less than 1 minute to list all of this. So you've got plenty of time. People tend to doubt how much work they can do in a couple of minutes. Don't. You'd be surprised by how long of a list you could make quite easily in a couple of minutes. The point is just you cannot just sit there and stare down the problem, because the problem will win the stare down and you will lose it. So, yeah. Extreme cases, sure, although then you're going to have a hard time proving that case. If you put it together, then there's a question in the text box that says, is n between 0 and 7 or any number? That question sounds like the author still is struggling with the very basics of how data sufficiency problems work. So if that's the case, we definitely can't explain all of data sufficiency right now. But I will give you the short answer, which is if you combine the statements, then you know n has to be between 1 and 5. So then that would be sufficient. If it's between 1 and 5, then it has to be between 0 and 7. That's why this works. But it sounds like the question makes it seem like the person asking the question needs to go read up on the basics of how data sufficiency works first, which we can't sideline the whole class for that. But you can, send an email or something like that. I can point you to the right resources. Okay, let's do one more shot. Yeah. Again, people who are commenting in the comments about this is too slow, I want to do another problem, please don't tell us how to run our own study hall. Thank you. Here's a problem. One more. Here's the question. I'll give you about 1.5 minutes, 1:45. And please use the A through E answers over on the left. Thank you. a word of warning to people who are answering these things too fast. Right now we had about 15 answers in the first 30 seconds, and 13 of them were wrong. So you might want to give the problem a little bit more consideration before you answer it. Go ahead and take another 30 to 45 seconds. Even if you have to guess, please go ahead and guess. A couple of you don't. While you guys are wrapping up the guessing of this, just a comment about, you know, questions are welcomed in the text box. That's what the text box is for. But please don't do the following two things. Please don't, number one, please don't say a problem is easy or anything like that. That's sort of demeaning to other students. Nobody's done that in today's class, but we have had people say, oh, this problem is very straightforward or very easy or something like that. Actually, hilariously enough, of the 4 times I remember people saying a problem was easy in study hall, 3 of them got it wrong, which was kind of funny. But please don't do that. And then also, please don't try to direct the problems. Like, please don't say too slow, too fast. I mean, that's why we do the smiley faces for do you understand and things like that. So that, I mean, sometimes I'm a little surprised by how fast or slow the pace is, but the class determines the pace. I mean, there's 40 or 50 people here, so the collective determines how fast we go. Okay, here are people's answers. Again, people are all over the place with this one. B, by the way, which is the majority answer, is not the correct answer this time. So let's take a look. What is the median of the 3 integers? So let's take a look at statement 1 first. So what do we do with this average? Again, as a quick reminder, it was in that color last time too. What do we do with an average? We transform that into n, or a what? We find the sum. So given average is 3 and the count is 3, the sum of the things has to be 3 times 3 equals 9. So the sum is 9. Statement 1 says that one of the numbers is 5. Okay, also happening in the text box is probably the other thing that people shouldn't do, which is to kind of like pester for what is the answer. We'll get there. I mean, remember, when we do these problems, the point is not the answer to the problem. Like, if you're doing problems and your main focus is answers, you will not get better at this test. You won't. When you do the problem, the point is to learn things about other problems. Like, for instance, this problem we just got done doing, the point of doing this problem is not to get the answer. Ultimately, who cares what the answer is? The point is to figure out, okay, median means I should think in terms of ordered blanks. Average means I should do the sum. Minimizing means I should maximize other quantities, or maximize means these are the lessons that matter. You really do not care about the answer to a practice problem. It's nice to get them right, but that's not going to help you improve. Improvement is a function of actually studying the takeaways that you get from the problem. So people who are pushing for the answer are probably, if that's your attitude towards studying, that's probably not going to get you very far. Okay. Statement 1 means one of the numbers is 5. Now, the thing to notice here is this. These have to be different positive integers. Does anybody have any idea where we go from there? Like, what does that mean? What does that mean we should do? Or at least, yeah, we should investigate, because these are very small numbers, and one of them is already really big. So we should look at this and say, hey, you know, there definitely aren't going to be a lot of ways of doing this. to do this. So remember what we said. In any problem where that happens, you should instantly have an instinct to just enumerate everything that can possibly happen. I mean, this is a lot more important than you would think it is, because this is a test where this test really does not want people who are algebra jockeys to do well. I mean, a lot of people don't believe when we first say this, but the entire reason that this test is what it is because it's hostile to people who just use textbook algebra type methods. So this is especially important because lots of problems are basically engineered to be hostile or even impossible for students who just use like standard algebra. I mean, they really are. So on a problem like this, you should suspect that something is going to be not right if you just try to use regular algebra. And in this case, that's exactly what happens. You've got one number is 5. So the other two numbers have to add up to 4. There's only two ways to do that with positive integers, either 2 and 2 or 1 and 3. And then tell me about 2 and 2. No, the mean will be right, because I mean the mean is still 3. You just can't do it because they have to be different. So you have to read the problem really carefully. So this is not okay. They're not different, but these are different. That's supposed to say not okay, not box. So there you go. This is the only possibility. The only way you can do it is 1, 3, 5 in ordered blanks. And so your median is 3. So this is sufficient. And this is definitely sufficient because you have a whole list in this case. So you can find anything. Okay, now 0 is not positive. Question is, what's wrong with 0 and 4? 0 is not a positive number. So it doesn't count. Okay, statement 2, let's go ahead and just copy this onto the next page. Okay, let's look at statement 2. And then we're going to wrap it up after we look at statement 2. Statement 2 is, again, the sum is still 9. So, I mean, I'll give you two ways to do this. The first way is just to make a list again. So you have one of the numbers is 3, and then you have two other numbers where 2 blanks add to 6. So there's a couple ways you can try that. 3, 1, and 5. 3, 2, and 4. 3, 3, 3. So we can't use 3, 3, and 3 because those are not different. But then we got to put these in ordered blanks. So ordered blanks here are 1, 3, and 5, and the ordered blanks here are 2, 3, and 4. So it turns out, even though there are two possibilities, that the median is the same. So there you go. So median must be 3, and this is sufficient. The other way to do it, you can actually do this one by thinking about theory and ordered blanks. Here's a quick summary of the information behind that. If you make your ordered blanks, then the deal is that the average is 3. So the other two numbers sum to 6. And they have to be different. So this means that 1 must be more than 3, and 1 must be less than 3. I mean, this is actually sort of general reasoning, like same thing if you had two different numbers that added up to, for example, 100. If they were different, one would have to be more than 50, and one would have to be less than 50. So that's the observation here. The other two numbers add to 6, and they're different. So one is more than half of 6, and one is less than half of 6. So yeah, the other way you can do it is what James is typing in his box over there. Since the average is 3 and this is 3, then if you realize what residuals are, overs and unders, you got to go over 3 on one and under 3 on the other one, because otherwise your average won't be 3. So that's less. I'll go ahead and type that up in a second, actually. This is going to be something less than 3. Sorry. This is going to be something more than 3. So your median's going to be 3. Actually, yeah, James's insight was a good one, so let me just type that up before we quit. Third way to do it is to think about residuals, or which is also thought of as overs and unders. Your average is 3, and one number is 3. I mean, your overs and unders have to add to 0. You have to have as much over positive residuals, if you know what that means. So one number is greater than 3, and the other is less than 3. If you don't know what residuals, overs, unders are, this is discussed in our word translations strategy guide. So you can pick up a copy of that if you don't know what we're talking about there. Okay. Yeah, and then the greater than 3, right? That's why you can do this. So overall answer to the problem then is D, because each of the statements was sufficient. So there you go. Okay, we're definitely over time here, so we're going to call it quits. If you have any quick questions, I'll take them real quickly. Remember, don't submit problems here. This is not the place to submit problems. If you need to submit problems, then just go to the Thursdays with Ron website, and there's a form with which you can submit the problems. But if you have any quick administrative questions or anything like that, I'll take those now. If not, I'm going to stop the recording.